What's up, y'all? It's Mr. Canada. In this video, we're going to be talking about how to calculate the rate of change using the idea of slope and the slope formula. This is the second part in our discussion about rate of change. In our first part, we were talking about what rate of change was and how it applied into various word problems and the types of lines that it created. So if you haven't looked into that video first, I would recommend it. But if you just need help calculating rate of change, this is the video for you. So let's go ahead and get started. So one of the most important things that you have to know is that rate of change is the exact same thing as the idea of slope. So you might hear that a lot from your math teachers, that rate of change, so ROC, is the exact same thing as calculating slope. So that means that things like the slope formula from 2 points, a table, or rise over run will apply exactly point by point. So just to recap, let's go ahead and talk about the slope formula. So the slope formula is the one that's on the following: y2 minus y1 divided by x2 minus x1, where x1, y1, and x2 and y2 are 2 points that are given to you, either that on a table, graph, or just quite literally 2 points on a paper. So how exactly do we find the slope or the rate of change from 2 points? Something that I really like to do is remind myself, what is the slope formula? So in this case, remember, the slope formula is y2 minus y1 divided by x2 minus x1. And one other really helpful thing that you can do to make yourself super successful with these types of problems is to label what is x1, y1, what is x2, y2. So one thing that I like to do is just say that this is x1 and this is y1, and say that this is x2 and say that this is y2. Just by doing as simple as just labeling my numbers, I'm already giving myself a lot of organization to knowing where the numbers are going to be plugged in. So let's say that we wanted to calculate the slope here. Well, the slope, m, can be easily calculated in this way: y2 minus y1. Well, what here is my y2? Well, it's negative 7. So negative 7 minus, well, what's my y1? It's negative 19. So put parentheses, negative 19, divided by, okay, what's the x2? The x2 is right here. We labeled it. It's negative 2. Minus, well, what's our x1? Well, we labeled it. It's 1. So this is going to be, I'm going to go ahead and put parentheses there too. That's going to be 1. All we're going to do now is just try to simplify the numerator, the stuff on top, and simplify the denominator, the stuff at the bottom. So what we're going to do is we're going to take out our calculator, or you can do it mentally, it's up to you. I have the decimals calculator right above me today. So we have negative 7 minus, put parentheses, negative 19. And if we press enter, that's positive 12. So this is going to be positive 12 divided by negative 2 minus 1 is going to get me negative 3. So then 12 divided by negative 3 is negative 4. So this is your slope. Likewise, this is also your rate of change. So recall from the last discussion video about this. If your slope or your rate of change is negative, you should be expecting a line that's going down. So just keep that in mind. So this is our slope. It is negative 4. This is our rate of change. It is negative 4. Let's go ahead and apply it one more time. So x1, y1, x2, y2. So then our formula is y2 minus y1 divided by x2 minus x1. So from here, what we're going to do, again, let's go ahead and plug them into the right spot. Okay, what's my y2? Well, my y2 is negative 4. Minus, well, what's my y1? It's positive 7, so minus 7. Divided by, what's my x2? Well, my x2 is negative 6. Minus, what's my x1? It's negative 4. I'm going to put parentheses around everything. And again, all we're going to do from here is try to simplify as much as we can. So again, you can use the calculator that's right above me at decimals.com, or you can use the calculator in your phone. Or if you have a real calculator, you can use whatever you want. So negative 4 minus 7 is going to get you negative 11 divided by negative 6 minus negative 4. That should get you a value of negative 2. Now, if you simplify this, you're going to get a positive decimal. In this case, remember, when you divide two negatives, you get a positive. So you can write your answer in two different ways here. You can either say that this is positive 5.5, or you can also say that it's positive 11 over 2, because that fraction can't be simplified anymore. It's already in its lowest terms. So these are basically the same answers. So it's your choice. So this is going to be your slope for this example, 5.5 or 11 over 2. So what's the idea? Basically, label your points. It makes it that much easier to put the numbers in, to plug them in, and just simplify either mentally or using a calculator. So let's go ahead into our next examples and let's review how we can find slope from a table. So how exactly do we find slope from a table? There are a variety of ways that you can do this. So I'm going to show you both ways, and then you go ahead and choose a way that you're comfortable with, okay? So one of the ways that you could do this is think about what the jump is between each x, and think about the jump between each y. The slope for a table is basically the change in y, delta y, over the change in x, delta x. If you haven't seen this triangle symbol, that's basically a Greek letter saying that this is the change of. It's a shorthand way of saying change of or change in, okay? So I'm going to be using this a lot moving forward. So think about how much your x's are changing by. Well, my x's are always going up, so that means that we're adding something each time. But by what number are we adding each time? Well, from 2 to 5, that's a difference of 3, so that means I'm adding 3. Is that true for the next one? Well, 5 to 8, that's again plus 3, and from 8 to 11, again that's plus 3. So there's a consistent plus 3 across my x's. Okay, what about my y? Well, from 11 to 17, it looks like I'm adding 6. From here to here, I'm adding 6. And from here to here, I'm also adding 6. So that means that my y's are constant and my x's are constant. So my rate of change, or my slope, is going to be my change in y, which in this case was 6, divided by my change in x, which in this case was a positive 3. And if we divide 6 divided by 3, that means my rate of change, or my slope, is going to be positive 2, which means my graph is going up. So now, what's the second way you could do this? Well, the second way you could do this is you can choose any 2 points from your table and basically apply the slope formula. What I'm going to do is that I'm going to go ahead and choose the first 2 points, and I'm going to apply the slope formula and see if I get the same answer. So one thing that you can do here is say that this is your x2, y2, and say this is your x1, y1, just because it's in order, because the first point comes on top and the second point comes at the bottom. So again, what is your slope formula? Well, my slope formula is y2 minus y1 divided by x2 minus x1. My y2 here is 17 minus my y1 is 11 divided by, what's my x2? Well, my x2 is 5 minus my x1 is 2. And all we're going to do is simplify. So 17 minus 11, that's going to get you 6, divided by 5 minus 2 is 3. And hey, look, we get the exact same quantities. 6 divided by 3 is going to get you positive 2. So notice that whether we use the change in, basically the jumps, or whether we use the slope formula, we basically end up getting the same quantity. Now again, you can choose whichever way you want, but I would always say that the safest way of calculating the slope will always be using the slope formula, the safest way and the guaranteed way. So let's go ahead and try to use that same idea here. So again, what we're going to do is we're going to try to figure out how much we're jumping by between our x's and y's, and try to figure out what the rate of change or the slope is. So notice that these numbers are getting bigger on the negative side. That means that you are subtracting a number each time, because basically the bigger your negative is, the smaller the number it is. So from here, from 3 to 7, it looks like I'm going down by 4. From 7 to 11, it looks like I'm going down by 4 again. From 11 to 15, and going down by 4 again. What about over here? Well, my numbers are going up, so that means I'm adding something each time. But what number am I adding? Well, from negative 10 to 0, I basically have to add 10 to cancel it out. From 0 to 10, that's plus 10. From 10 to 20, again, that's plus 10. So my slope remember, is my change in y divided by my change in x. So my change in y was positive 10, and my change in x was negative 4. So if you simplify this fraction, you're going to get an answer of, well, 2 goes into both of them, so this will be an answer of negative 5 over 2. Or if you're going to put this into decimal form, this is the same as negative 2.5. So this is going to be the same slope regardless of whether you keep it in fraction form or whether you keep it in decimal form. Again, you can check that on a calculator. Now, let's apply the slope formula here just to make it a little bit easier. Slope formula, m, y2. So this is going to be, let's label here, x1, y1, x2, y2. Now m equals, the slope is y2 minus y1 divided by x2 minus x1. So what's our y2? y2 is 0 minus what's y1? It's negative 10 divided by what's x2? It's going to be negative 7 minus what's x1? Negative 3. So from here, 0 minus negative 10 is positive 10. Negative 7 minus negative 3 will get you a negative 4. And notice that we end up getting the exact same thing we got earlier. So that'll lead up to the previous answer. Let's go ahead and look at its slope from a graph. So slope from a graph, what I'd like to use is using the idea that m is rise over run. The slope is rise over run. The rate of change is rise over run. I always recommend that when you are looking for rise over run from a graph is that you always start from the left point and you end up at the right point. What if there are no points on my graph? Then your first task should always be find 2 points on the graph that you can work with and then figure out the rise over run. So how does that work? Basically, you have 2 points. What we're going to do is that we're going to create a triangle between those 2 points. Now, it doesn't matter whether you create that triangle above the line or below the line. It's going to be the exact same thing. All you're going to do is this. To calculate the rise, you're going to be looking at the part that's going up and down. To calculate the run, you're going to be looking at the number of spaces that are going from left to right, the little flat part of the triangle. So think about this. If you're going to start at this point, my left point, think about what you have to do to end up here. Well, that's going to be going 1 square in the up direction. So that's going to be plus 1. So from here, think about how many spaces it is from the left to the right, the flat part. Well, from here to here, it's 1, 2 spaces. So that means that your rise went up by 1 and your run was going to the right by 2. So that means that here your rise, the part that goes up and down, is plus 1, and the run, the part that's flat, is plus 2. And if you simplify this, this is just 1 over 2 or just 0.5. So this is your rate of change. This is your slope. Remember, because your slope is positive, what kind of line should we expect? We should be expecting a line that's going up, that's increasing. So our answer, the sign of our answer, matches the type of line that we have. Okay, let's go to the next one. Again, let's apply this idea of rise over run. Again, let's go ahead and start from the point on the left and end up at the point on the right. That means we're going to start over here and then we're going to end here. For the sake of this example, I'm going to make my triangle below this time. So remember that the part that goes up and down is your rise, while the part that's flat is your run. So from here, that means that my rise is going 1, 2 spaces down. So that means this is minus 2. And then my run is going to be 1, 2 spaces to the right. All my positive numbers are to the right. Anytime you go to the right, that's going to be positive. So what's my rise? Well, my rise was negative 2 because I went down 2 spaces. And my run is positive 2 because I went to the right 2 spaces. Now if we simplify, this is going to get you -1. So this -1 is your slope, or in other words, this is your rate of change. Now again, because our rate of change or our slope was negative, what kind of line should we expect? We should be expecting a line that's going down, and that matches what we have here. So that means the sign of our answer matches the type of line that we have. So we did all the work right. Now there are two special cases of rate of change that I would like to cover with you guys. And for this example, what I would like to do is use the slope formula. So x1, y1, x2, y2, x1, y1, x2, y2. So let's apply the slope formula here. So rate of change or slope is y2 minus y1 over x2 minus x1. So what's the y2? In this case, the y2 is 6 minus y1 is 8. And then finally, x2 is 10 minus y1 is also 10. So you're going to notice that 6 minus 8 is -2, divided by 10 minus 10 is 0. Now, if you try to put this into your calculator is going to get you an error. Why is there an error? The reason why we have an error here is because you are dividing by a value of 0, and that's undefined. So anytime that you are dividing by 0 here, then we can say that your slope or your rate of change is undefined. And that only happens when the 0 is at the bottom, when you're trying to divide by 0. So whenever you have this, that basically means that your slope is undefined. Okay, let's look at the next example. Again, slope is y2 minus y1 over x2 minus x1. y2 is 5 minus y1 is also 5 divided by x2 is 8 minus x1 is 9. If you simplify this, you're going to get 0 on top because 5 minus 5 is 0. And at the bottom, you have 8 minus 9, which is -1. Now, when you do 0 divided by -1, you're just going to go ahead and get a slope of 0. And you can verify that on a calculator. So these are the two special cases of slope. Sometimes your slope is undefined or your rate of change is undefined whenever you have a 0 in the denominator of your fraction. But on the flip side, your slope can sometimes be 0 if the 0 is located on the top part of your fraction. So these are your two special cases. Well, I hope you guys learned something new today. If you have any questions, please leave them in the comments below and I'll get to you as soon as I can. If you liked the video, give this video a like and subscribe to my channel for more Algebra 1 videos. And as always, please take care and I'll see you guys next time.